Something ancient just brushed past our sun, and it may have started its journey before the sun even existed. Not thousands of years before, not millions, possibly billions. A frozen traveler from another star system swept through our cosmic neighborhood in 2025, and when astronomers pointed the most powerful space telescope ever built directly at it, the readings that came back left seasoned scientists genuinely stunned. Stay with me, because by the end of this, you will understand exactly why researchers are calling this one of the most extraordinary natural discoveries in modern astronomy, and why some corners of the internet spiraled into wild theories the moment the data started coming in. If stories like this pull you in, go ahead and hit that subscribe button now, and drop a comment below telling me where in the world you're watching from, because I love seeing just how far this curiosity about the universe travels. To understand why this particular visitor mattered so much, you first need to picture our solar system the way it really works. One star sits at the center, and everything else, the planets, the moons, the asteroids, the comets, all of it is trapped in a gravitational leash that never lets go. Each of these objects loops around the sun again and again, bound forever to the same orbital path. That is the rule. That is how almost everything in the sky behaves. But every so often, something breaks that rule completely. Something arrives that was never born here, never caught by our sun's gravity, and never intended to stay. It slices through our solar system on a single pass and then vanishes back into the galaxy forever. We call these rare wanderers interstellar objects, and in the entire span of recorded human history, we have only ever confirmed 3 of them. The first was spotted in 2017. A strange, elongated shape tumbling through space in a way nobody had seen before. It offered almost no activity for telescopes to study and disappeared from view before scientists could unravel most of its secrets. The second arrived in 2019, behaving far more like a familiar comet, complete with a glowing tail, giving researchers a richer set of data before it, too, slipped away into the dark. Both encounters left astronomers with the same nagging frustration. Too little warning, too little time, and instruments that fell short of what a truly detailed investigation would require. What they were really waiting for was a third chance, a bigger, brighter, more cooperative visitor that would give the world's most advanced telescopes enough time and enough light to actually do their job properly. That chance arrived on July 1st, 2025. A telescope system in Chile, built specifically to scan the night sky for anything that moves in ways it shouldn't, picked up a faint point of light racing across its images. Within days, orbit calculations confirmed what astronomers had hoped for and feared for years. This object was not orbiting the sun. It was cutting straight through our solar system on a path so steep, so extreme, that nothing bound by our star's gravity could ever move that way. It had come from somewhere else entirely, and it was already on its way back out, never to return. This became the third confirmed interstellar object in human history, and it earned the name 3IATLAS, a nod to the very telescope network that first caught sight of it. From the moment its trajectory was confirmed, something about this object stood apart from the 2 that came before it. Its path bent around the sun more sharply than any interstellar visitor ever measured, a clear signature of an object with almost no attachment to our star whatsoever. It was moving at a jaw-dropping speed, well over 200,000 kilometers an hour when discovered, and it kept accelerating as it fell closer to the sun. Here is where the story turns genuinely strange. By comparing its velocity to the average motion of stars throughout our region of the galaxy, scientists were able to roughly estimate how long this object had been drifting alone through interstellar space since it was first flung out of whatever star system created it. Their calculations placed its age somewhere between 3 billion and 11 billion years. Our own sun and solar system are roughly 4.5 billion years old, which means it is entirely plausible that this frozen wanderer formed around a star that had already died out long before our sun ever ignited. Picture that for a moment. A fragment of another solar system, possibly older than our own, drifting silently through the emptiness between stars for billions of years, untouched, unheated, alone, until it happened to cross paths with us. And unlike the very first interstellar visitor from 2017, which stayed almost eerily quiet the entire time it was observed, this new arrival turned out to be dramatically active. As it approached the sun and began to warm, frozen material locked beneath its surface started converting directly into gas, streaming outward and forming a glowing halo known as a coma, trailed by a faint tail. For astronomers, an active object is a gift, because it releases its internal chemistry into space where instruments can actually read it, instead of keeping its secrets locked away forever. None of this would have been possible without an extraordinary amount of advance warning. Because the detection came so early, astronomers worldwide had months to prepare before the comet made its closest pass by the Sun. That lead time let space agencies schedule precious telescope time well ahead of the event instead of scrambling at the last second, something the earlier two interstellar visitors never allowed for. Once the object's origins were confirmed, observatories and space telescopes across the globe began lining up, one after another, to take their turns studying this ancient traveler. The most anticipated of them all was the James Webb Space Telescope, humanity's most sensitive eye on the universe. Unlike ordinary telescopes, Webb reads infrared light, wavelengths longer than what our eyes can perceive, allowing it to detect faint heat signatures and chemical fingerprints invisible to almost everything else. Webb was never designed with a fast-moving object like this in mind, and tracking something racing across the sky at such speed pushed its systems to their limits. Even so, engineers managed to lock the telescope onto the comet in August of 2025, capturing its very first detailed chemical spectrum. Then, after the comet swung around the Sun and began heading back into deep space, Webb observed it again in mid-December using a completely different instrument, tuned to a different slice of infrared light, producing the most detailed chemical readout ever recorded from an interstellar object. What came back from that data floored a lot of scientists. The chemistry of this visitor did not match the comets we know from our own solar system. It carried an unusually high ratio of carbon dioxide compared to water vapor, breaking a pattern astronomers have observed for decades in comets born right here at home. That alone suggested this object formed in a chemical environment fundamentally different from our own. Then came the discovery that truly changed the conversation. Buried in the mid-infrared readings, scientists identified a clear signature of methane gas escaping from the comet, the very first time methane has ever been directly detected coming from an interstellar object. Alongside it, Webb also picked up unmistakable water vapor, and then something nobody expected at all, a distinct atomic signal belonging to nickel drifting off the comet's surface. To understand why the methane discovery mattered so much, you need to know just how fragile that molecule really is. Methane is small, lightweight, and highly vulnerable to cosmic radiation, the exact kind of relentless bombardment an object drifting alone through interstellar space for billions of years would never escape. Scientists genuinely did not expect much methane to survive on the outer surface of something this old. Finding a strong signal of it meant the gas had to be coming from somewhere deeper, from material buried beneath the surface that had been shielded from radiation for eons, only now being exposed as the comet's outer layers boiled away in the heat of our sun. In other words, Webb was not simply looking at the surface of this ancient wanderer. It was staring straight into material that had remained sealed away since before our solar system existed, untouched by anything, until this exact moment in history. Webb was not working alone. NASA's Hubble Space Telescope also turned its lens toward the comet, first shortly after discovery, and again after its closest approach to the Sun. Hubble's early images gave scientists their first rough estimate of the solid nucleus buried beneath all that glowing gas and dust. Later, once the comet's activity had calmed down, researchers managed to separate the faint glow of that solid core from the brighter surrounding cloud, arriving at a refined estimate of roughly 2.5 kilometers across, notably larger than either of the two interstellar objects discovered before it. That extra size mattered enormously, because a bigger surface means more material available to heat up and release, which in turn produces a brighter coma and a stronger chemical signal for instruments like Webb to capture in detail. Other instruments joined the effort too. A sky-surveying infrared telescope observed the comet in December, picking up signs of increasing activity after its closest solar approach, along with detecting tougher, heat-resistant dust mixed into the coma. Ground-based radio telescope arrays added even more pieces to the puzzle, detecting additional molecules escaping from the comet, including methanol and hydrogen cyanide, each one another clue about the raw ingredients baked into this object long before it ever encountered our Sun. Now, because this object moved on such an extreme path, and because it turned out to be surprisingly large and surprisingly old, certain corners of the internet ran wild with speculation, suggesting it might not be natural at all. That kind of curiosity is a normal human reaction to something unexplained, and rather than brushing it aside, scientists took it seriously enough to actually check. Researchers pointed radio telescope arrays specifically built to search for artificial signals, listening carefully across a wide range of frequencies as the object passed through our solar system. The result was unambiguous. No artificial signals were ever detected. Every single piece of evidence gathered, from Webb's chemical readings to Hubble's imaging to the dedicated radio searches, points to exactly what a natural, ancient comet should look like. Its motion follows known cometary physics. Its chemistry, while unusual, fits within the range scientists expect from an icy body formed around a different star. There was nothing constructed, nothing artificial, only an extraordinary natural relic from somewhere else in the galaxy. So why should any of this matter to someone who isn't an astronomer? Because every interstellar object we manage to study up close hands scientists a genuine physical sample of material built around a star system we will likely never visit or directly observe in any other way. Instead of only guessing what other star systems might contain based on distant starlight, researchers can now measure actual raw ingredients from somewhere else in the galaxy. That is an almost unbelievably rare opportunity, and in all of recorded history, we have only had 3 chances like it. This third one gave scientists by far the richest data set of the group, thanks to its size, its activity, and the sheer amount of modern instrumentation available to study it, tools that simply did not exist back in 2017. There is a bigger picture forming here too. For years, astronomers debated whether interstellar visitors were vanishingly rare one-off events or whether space is actually full of them, quietly slipping past us undetected simply because we lacked the tools or the timing to notice. Confirming 3 of these objects within less than a decade, with detection technology improving every single year, suggests these wanderers might be far more common than anyone originally assumed. A powerful new ground-based survey telescope recently began full operations, purpose-built to scan the entire visible sky every few nights with extraordinary sensitivity, and many scientists expect it to dramatically shorten the time it takes to spot the next interstellar traveler after it enters our solar system. More warning time means more opportunities to prepare our best telescopes in advance, instead of racing against the clock the way teams had to back in 2017. Take a moment to really absorb the full timeline of what this object has actually been through. It formed billions of years ago around a star that may no longer even exist, somewhere in a completely different region of the galaxy. At some point, a gravitational disturbance, perhaps a close encounter with a passing star, flung it out of that system entirely, sending it drifting alone through the freezing emptiness between stars, with no sun to warm it and nothing to shield it. For possibly billions of years, it tumbled through that silence, carrying its original chemistry locked away and frozen solid. Then, purely by chance, its long journey brought it close enough to our sun for our solar system's gravity to finally bend its path, and for our telescopes to finally notice it. It swept past our star, warmed just enough to release a portion of that ancient material into space, gave our instruments a brief window to read its secrets, and then continued on its way, heading back out into the depths of the galaxy, likely never to be seen again. Consider how narrow that window really was. Telescopes themselves have only existed for around 400 years. Instruments capable of reading the precise chemical fingerprint of a comet have only existed for a few decades. Out of the billions of years this object spent drifting silently through the galaxy, it happened to pass near our sun during the one narrow sliver of human history when we possessed both the knowledge to recognize it as interstellar and the technology to study it in real time. A few hundred years earlier, it would have simply been an unexplained smear of light in the sky, gone before anyone understood what they were looking at. We happened to be alive, with the right instruments pointed at exactly the right patch of sky, during the one brief moment this ancient traveler passed close enough to notice. That is an extraordinary stroke of cosmic timing, and it took teams of scientists, engineers, and observatories across multiple continents working together, sharing data within days of discovery to make the absolute most of it before the comet faded from view for good. Researchers are still combing through everything Webb, Hubble, and every other instrument managed to capture, and findings have already been formally published in a leading scientific journal, cementing this object's place as the most thoroughly studied interstellar visitor humanity has ever encountered. Every new detail adds another piece to a much larger puzzle: how solar systems form, how common these ancient wanderers actually are, and what raw materials might be scattered throughout other star systems across the galaxy. Somewhere out there right now, more fragments of other solar systems are almost certainly drifting through our own, ancient, frozen, and completely unnoticed, waiting for the next telescope powerful enough and lucky enough to catch them before they slip back into the dark. To bring it all together, in the summer of 2025, a fast-moving object appeared in our sky, and within days, scientists confirmed it did not belong here at all. It was the third confirmed interstellar object in recorded history, and it turned out to be one of the most extreme ever measured, tracing the sharpest hyperbolic path astronomers had ever recorded. Estimates suggest this ancient traveler could be anywhere from 3 to 11 billion years old, meaning it may have formed before our own sun ever existed. As it swept past the sun in October of 2025, it warmed up and came alive, releasing gas and dust that our most advanced telescopes were finally able to study directly. The James Webb Space Telescope captured unusually high carbon dioxide levels, the first confirmed detection of methane ever recorded from an interstellar object, clear water vapor, and even a rare nickel signature, all pointing toward chemistry forged in a completely different star system than our own. Hubble helped pin down its size. Additional infrared and radio observations added even more chemical detail, and dedicated searches for artificial signals came back completely empty, confirming this is exactly what it appears to be: a genuine, ancient fragment of another solar system passing quietly through ours before disappearing back into deep space, likely forever. That is the real story, built entirely on verified data gathered by real telescopes and real scientists working together across the globe to understand one extraordinary visitor before it vanished for good. If this gave you a new appreciation for what real space science can uncover, subscribe to this channel so you never miss the next confirmed discovery. Drop a comment below telling me what surprised you most and where you're watching from, and share this with someone who deserves the real story instead of the rumors. We'll see you in the next one.